To wrap up our blog, we'll show how we can use the hybrid agent approach to potentially improve the customer service AI agent that we built earlier. Let's start by copying all of the code as always. This would go agents, hybrid customer service. This goes here. Test conversations goes here. The shell script. And lastly, the build file. So let me show you how this is different. Well, you might remember that in the first customer service AI agent that we built, we only had a placeholder response. That's not very useful to the customer, right? It's good for Claude because Claude only gets the customer's responses, so it can track sentiments better. But the AI agent still has to respond to the user. Well, what can we do about it? If we rely on Claude or other paid models for that, it might not scale very well. Luckily, Hugging Face has a lot of useful models that are lightweight, that can perform satisfactorily well on device when fine-tuned correctly. This is still a work in progress, and this is not a final solution, but we were experimenting with small LM with 1.7 billion parameters. We were also experimenting with Google's Gemma 2B series of models. We couldn't get them to work yet, but we do see this going in a good direction. So what's different about this file? Well, it builds on top of the service agent file that we had for our initial customer service agent. The only thing it does different is it takes in the name of a Hugging Face model name and then all the way up. While initializing Claude, it also initializes the Hugging Face model, and then the evaluate transfer need function is the same. We do have a build Hugging Face prompt to send prompts to the model of our choice. Now this will be different for the model that you choose, but essentially it's the same. Just create a prompt for the model that responds to the users. And then in our generate response function, instead of just returning the placeholder prompt like we did in initial agent, first we call this new build HF prompt function to get a prompt, then we tokenize it, and then we get the model that we chose to process the tokenized input, and then we decode the output. Again, all of this decoding code is for the small LM 1.7 billion model. The models that you choose will have different decoding requirements. And that's about it. Everything else remains the same. And just to show you how this works, let me just execute it remotely. And instead of running it in all of our 24 test conversations multiple times, I'll just show it to you on this one sample conversation, because again, this is still a work in progress. So we're back with the response. As you can see, the model was tailoring its responses to the customer's message, but these aren't the best results. Now, the good thing is this model wasn't fine-tuned at all, so there's a lot of scope of improvement. We would expect the best results to be seen if a model is fine-tuned on a conversation dataset. But yeah, this is work for the future that we are just casting a light on now.